Hello everyone, welcome to section 6.2, adding and subtracting rational expressions. This is very similar to just adding and subtracting fractions in general. So if you have a good understanding of adding and subtracting fractions, which you should, then this should be pretty second nature to you, okay? So let's go ahead and get started with reviewing how we add and subtract rational expressions. If they have the same denominator, then we add numerators and keep the denominator or keep the base. Okay, so that's how we handle the same denominators. If they have different denominators, then we need to find a common denominator and change each expression so that they have the same value and denominator. Okay, there we go. Okay, and then finally we just simplify and reduce, okay? These first two examples are pretty straightforward. We see that they have a common denominator with 5 and 5, so we just add the numerators, 3y plus x. We can't simplify that any further, over 5, and there's nothing to cancel there, so that's our final answer. The second little example, we have m over m squared minus b squared plus p over m squared minus b squared. Okay, so we're going to keep the base as it suggests, m squared minus p squared, and we have m plus p in the top. Now, simplify and reduce. We recognize, or should recognize, that m squared minus p squared is a difference of squares. So we're going to write m plus p over, and this becomes m plus p times m minus p as our difference of squares suggests. Okay, once we see that, we can simplify the m plus p in the top with the m plus p in the bottom. We cancel that. We're left with 1 in the top and m minus p in the bottom. And that becomes our final answer. So make sure you check for all these indicators that we can factor further and reduce. Okay. Next up, we have the tough part, which is finding a least common denominator. Okay. So the first thing we're going to do is we're going to factor each denominator, like I showed you above right here. We factored that denominator. And then we're going to find the least common denominator. Okay. The LCD is the product of all, oops, let me use purple here so it stands out. Purple. Prime, product means multiply, prime factors using the highest degree for common factors. That last little bit is just saying you got to use the biggest number if we're finding a least common denominator. For example, if we're talking about the numbers 4 and 16, and we're talking about a least common denominator between the two, okay? Well, we recognize that we have 2 and 2 as factors there, and 16 is 2, 2, 2, and 2. So there's 4 2's multiplied together to get you your answer to 16, okay? So the highest degree of the common factors, common meaning they share the same factor. So we can't just put 2 is the prime factor, so that's the common denominator. It's not, okay? It's the highest degree for common factors they share. So 4 can be rewritten as 2 squared. 16 can be rewritten as 2 to the 4th. So we have to use 2 to the 4th as our least common denominator, or 16. So 16 in this case is our least common denominator, okay? So anytime we have shared numbers, shared prime factors, we have to use the highest degree found in either number, okay? So let's put this into practice so you can kind of see what I'm talking about. So here we have 7 over 15 plus 5 over 12. If we break it down into its prime factors, 15, we have 5 and 3, okay? Plus 5 over 4 times 3, which really is 2 times 2 times 3, okay, breaking down into prime factors. Now, what are all the factors that we need to multiply? Well, we need to multiply a 5, a 3, and 2 2's. Do we have to multiply this second 3 to find the least common denominator? The answer is no. The highest degree in either one of these is 1. There's only one 3 found in 7, and there's only one 3 found in 5. Okay? But there's two 2's found in 5, so we have to use both of those. Okay? So our new denominator is going to be this. It's going to be 5 times 3 times 2 times 2. So we need to change these denominators so that they have that as their least common denominator. Copy, paste. 5 times 3 times 2 times 2. Okay? Now, what are we missing from the 7? Okay? Before we only had the 5 times the 3 with the numerator of 7. So we have to change this 7 to match the denominator, and we need to multiply the remaining 2 times 2 to the top to keep it balanced, to keep the value of the fraction. Okay? Let's scoot over to the 5. What did we change from the 5? Well, we had the 3 and the 2 already multiplied to get us 12, but we're missing the 5. So we still need to multiply by the 5 in the top to keep the value the same. Okay? Now, what happens? Well, 5 times 3 times 2 times 2 is the same thing as 60. So we know our denominator is 60, our least common denominator. In the top, we get 7 times 2 is 14, and then 28. And then 5 times 5 is 25. Now they have a common denominator. We are ready to roll. We're going to keep the base the same, 60, okay? And we're going to add the top. 28 plus 25 is 53. And that is our final answer, okay? Now, it also says we need to reduce if possible, but there's nothing to reduce here, so we are done, okay? What I'm going to do is I'm going to shrink wrap this just so we can move it out of the way for our next problem, okay? But feel free to pause and reference this anytime. Next problem. Okay, now we have some variables, which is okay. We need to break it down into its prime factors again. 5 over 2 times p. Those are both prime. Plus 3 over 2 times 2 times p. Okay? This is a great example of you got to use the highest degree. Here we have a 2, but we just can't multiply it once. We have to include both because this fraction, the highest degree is 2. 2 to the second power. Oh, I'm sorry. I'm missing a 2. 2 to the third power. Because 2 times 2 times 2 is 8. Whoops. Okay, so we have to multiply 2 to the third power. That needs to be in our denominator. Okay, now we don't need to multiply it by the fourth 2. Okay, we only have to have the highest power in one of the denominators. Okay, so as we rewrite this, okay, equals, we know our new denominator has to be 2 times 2 times 2 times p. Not 4 2's, only 3, because that's the highest degree. Okay, now what are we missing for the 5 so that it matches the denominator? Well, we had the 2p before, but we're missing these other 2 2's. So we have to multiply by 2 times 2. Now the 3, what are we missing from the 3? It already had 2 times 2 times p, 2 times 2 times 2 times p in the denominator. So we're good. Look, there's nothing new added, so it stays the same. Okay? So really, when we break this down further, we get 5 times 2 times 2, which is 20, over 8p plus, I forgot the plus up here, 3 over 8p. Keep the denominator the same, equals 8p, and then in the top we have 23.